imagining you're speaking to a person who has obesity, has a high school education, and is vaguely interested in health. Could you give maybe 5 to 10 brief lifestyle recommendations that you think will help them quickly lose fat in a way that's relatively healthy?
Yeah, I can do that. I think I want to start by saying that there are new tools available for the medical management of obesity, especially the GLP-1 receptor agonist drugs. And so I think for someone who has obesity, I think it wouldn't be a bad idea to talk with a doctor about it at this point. For people who don't wish to do that, or people who might have a smaller amount of fat they want to lose, or people who uh, don't want to gain fat, people who are looking to avoid gaining fat, which most of us do in um, industrialized countries. I think that's more where the diet and lifestyle advice is most effective and appropriate. And yeah, so there are a number of different approaches you can take. There there are randomized controlled trials on many different diet styles that cause weight loss. So these are just some thoughts off the top of my head that are that I think are some effective approaches, but they're not necessarily mutually exclusive with other approaches. So I think one of the things that if it were, if I was designing a program for somebody, one of the things that I would start with is trying to increase the satiety per calorie of their foods. So the types of foods that most people eat are they tend to be low satiety. So they don't make you feel very full per calorie, which causes us to naturally eat more without really even thinking about it because we eat until we feel full. And so eating foods with a lower calorie density, that's fewer calories per gram, those are foods that are higher in water and fiber, more of the type of whole, unrefined foods that you might think of, like whole grains, fresh meats, um, fresh fruit, vegetables, foods like that, and fewer of the kind of bakery products. And bakery products are pretty much the worst in terms of satiety per calorie. Bakery products and candy and that sort of thing. Uh, Pizza and more kind of like highly processed, calorie dense, rich foods. That I think goes a long way because it helps you eat fewer calories without feeling unsatisfied. So I think that's one thing to start with is start moving foods in the direction of more lower calorie density, unprocessed foods. Another part of that I'll just mention is reducing added fats. So isolated fat is the most calorie dense substance in the human diet. And so fat isn't necessarily the enemy, but added fat is a very concentrated calorie source that doesn't give you a lot of satiety per calorie. So that is one thing you would want to limit. So that's one thing. The other thing that I really tend to focus on is improving the food environment because the human brain, things like cravings, eating drive, those things are very often triggered by environmental cues. You see a food, you smell a food, and that triggers a desire to eat that food. And if you hadn't seen it, if you hadn't smelled it, if it hadn't been right next to you, then you wouldn't have eaten it. And so, controlling your food environment is, I think, pretty important. There are a few different aspects to that I'll just gloss over for the time being, for the sake of being concise. And and another thing that goes hand in hand with that is not snacking. So if you look at the changes in the US diet that correlate with the obesity epidemic, one of the strongest correlates is that we snack more today. And in fact, the snacking that we do accounts for the increase in calorie intake that correlates with the obesity epidemic. So if you had if we subtract those snacks out, then that actually brings us back pretty close to the calorie intake that we had in the 70s before the obesity epidemic. And when I say snack, I'm also including sodas because that was a big part of the increase as well. People increase their between meal consumption of sugar sweetened beverages. So, I would say those are probably my top 3 right now, and, um, as you can see, they all revolve around diet because I think diet is the most powerful lever we have for modifying body fatness. And, however, if you wanna go further, I think that it's helpful to be regularly physically active. There's an energy burning component to that, but also it helps regulate your appetite. And, getting restorative sleep as well, I think can help regulate, appetite appropriately.
Fantastic. And I'm sure some of those things will come up again later in the conversation. But imagining it's now 1 year down the line and the person's lost a substantial amount of fat and they're now in the high end of the healthy range of BMI, would your recommendations differ at all? I know that there are data from the National Weight Control Registry, for example, showing that there are certain behaviors that help people maintain weight loss, which is notoriously hard to achieve. So, would your advice for someone who's now trying to keep weight off differ? Would you emphasize anything else?
Yeah, actually, I would place a greater emphasis on physical activity. There is some evidence that physical activity is particularly helpful with weight loss maintenance.
And as you said, that's both due to help with appetite control, but there might also be some contribution to total daily energy expenditure, which we'll return to because I know that's a subject of some controversy at the moment. But I'd
Yeah,
love to start to explore a few ideas in a bit more
yeah.
depth now. And you've long promoted the idea that the brain is the most important organ in regulating adiposity, hence the title of your excellent book, The Hungry Brain. And so I was wondering if you could give a high level overview of how the brain regulates food intake and adiposity. And could you, along the way, give some of your brief thoughts on two models that have particularly strongly influenced my own thoughts on this subject, namely the energy balance model and John Speakman's dual intervention point model?
Yeah, so okay. The I think a lot of people don't intuitively think of it this way, but explaining it helps to clarify how important the brain is for body fat regulation. The first thing is that the brain generates all behaviors, including all eating behaviors. And so, if you think eating behavior is related to body fatness, which I don't think anyone would deny that, um, then you think the brain is important. And the second thing is that the brain contains the only known regulatory systems for body fatness. And so the way it works essentially at a very high level is that there are two centers in the brain that cooperate to regulate body energy status. There's the center in the hypothalamus that regulates long term body energy status via regulating body fat. Body fat is by far the main energy storage site in the body, and it's even more by far the main modifiable energy storage site in the body. And so that is the amount of fat on your body is basically the amount of that's basically equivalent to your long term energy storage. And then you have another system in your brainstem that regulates your body energy status on the short term basis. And that more has to do with how much food are you eating on a meal to meal basis, how much food is there in your digestive tract. And those two obviously relate to one another. The short term eventually determines the long term. And so there are connections between those two in the brain. The short term regulatory system is highly interconnected with the digestive tract, and it takes a lot of information from the digestive tract. So your gut, your mouth, and your gut are constantly measuring, as you're eating, they're constantly measuring the chemical composition and volume of the food that you ate, and they're sending that information to your brain. So your brain knows how much fat, carbohydrate, protein, what the volume is, whether there are any bitter or noxious substances in what you ate, and lots of other information too. And that information accumulates in your brainstem as you're eating. With each additional bite, that signal kind of builds up. And then at some point your brainstem says, okay, you've had enough. And that is the point of satiety. And a point I want to make here that I think is really important is that satiety, we intuitively, I think most people kind of intuitively think of satiety as the point at which your stomach fills up. Like you have filled the space available in your stomach and there's no more room left, and that's what makes you feel full. But in fact, the stomach has a much larger capacity typically than what you would eat at a meal. So, what determines how full you feel is that brain activity in your hypothalamus. And I'm sure everyone's had the experience of, let's say they exercised really hard one day and then they were super hungry and they ate a big meal, and at the end of this huge meal, they weren't any more full than they would be at the end of a normal meal that was just like the right amount for that meal. And that's because, again, your state of fullness does not so much depend on what's happening physically with your stomach. It depends on the decisions that your brainstem is making about your energy needs versus the energy content of your digestive system. And so that's the short term thing. And then the long term system in the hypothalamus um, responds to a variety of signals and also exerts a strong influence on appetite. But one of the key signals is this molecule called leptin, which is a hormone that's secreted by fat tissue. And leptin is in your circulation, in your blood, in proportion to how much fat you have on your body. So if you have obesity, you have a lot of leptin. If you're lean, you don't have as much leptin. And the hypothalamus uses that concentration of leptin to measure how much fat is on your body. And then it responds accordingly. So if a person starts to lose fat, their leptin level declines, the hypothalamus senses that, and it initiates what I call a starvation response, which is a physiological and behavioral program designed to regain the lost fat. So the main aspect of this program is that your food intake goes up, or at least it tries to drive your food intake back up. Your cravings go up, your hunger go up, your attention is more biased toward food cues than it used to be, especially calorie dense foods. And then also, if you lose enough fat, it will start to turn down your metabolic rate as well. So it's hitting both sides of the energy balance equation. And that will continue until you regain that lost fat. And the thing that's perverse about this is that it happens in people with obesity similarly to how it happens in lean people. So, um, people with obesity, when they try to lose fat, they encounter resistance from the system in a way that's very similar to how it would happen for a lean person. So, for whatever reason, the so-called set point of where the hypothalamus wants to regulate around, what level of body fat it wants to regulate to, that goes up in people with obesity. And that makes it difficult for them to lose weight, and is the reason why people tend to regain some of the weight after they go on a diet.
And core to the original set point model is the idea that your body likes to defend a certain level of adiposity. But the distinction between that and the dual intervention point model is that there might be 2 points. So there's a lower bound where if you go below a certain level of adiposity, there are some changes that take place that effectively help conserve energy, reductions in energy expenditure, increases in food intake. But while there might have been an upper bound above which the body would start expending substantially large amounts of energy and also reducing food intake, and the hypothesis is that that could have been important to avoiding risks of predation, because if somebody was too fat, then it would have been harder to evade those predators. That upper system no longer functions so effectively. And so there might have been some drift in people's genetics over time such that that upper point is no longer defended. I don't know if you're aligned with John speaking on that, Stefan, but would you say that that's a fair representation of?
Yeah, I think so. And I think his concept, and I think it's been evolving, and I've spoken with him about this a couple of times. So we're in communication about this and having some good-natured debates about it. Um I think my understanding of his original idea was, and what you said is correct, but I just want to build on it. Is that this lower intervention point doesn't really move. And people, like, if you gain weight, that lower intervention point's down here, your weight's up here, and you're not like that would be different than the set point concept, which would be that your set point is moving up as you're gaining weight, and your kind of lower bound of defended fat is moving up with it. And the thing that, so I do think, let me put it this way, I think that there and probably are at least somewhat different mechanisms that are defending against weight gain and defending against weight loss. Um, and so in that sense, I think that's consistent with a dual intervention point. At the same time, I think it's really like we don't have the data to say whether it's actually a point that's being defended or a range between two bounds like he's proposing. I mean, yeah, there are different ways that you could explain the same data, and those two possibilities could both be consistent with it. I'm not aware of a way to distinguish between those. Um, but I think that one thing that has to be accounted for in any model is that people with obesity, their um, starvation response kicks in if they try to lose weight from their current place, from their current weight. So, whatever that lower intervention point is, it has to move up with them as they're gaining weight, because it's right there, right under their current weight. When they try to lose, they get pushback in most people. And so that's the part that I haven't seen his model accounting for, that I think is, to my read, is pretty clearly supported by the evidence. Um, if there was a lower intervention point that just kind of stays where it is when you're born, then it wouldn't be as hard to lose weight. You could lose weight and just kind of stay at the lower weight, and you would never cross that lower intervention point, so you would never experience pushback from your central nervous system. But you do see that pushback in people who lose weight. So I think, I use the term set point in my public communications because it's an easy concept to convey. It's like your home thermostat, right?
I just want to return to something you mentioned earlier, namely processed food. And obviously, we're surrounded nowadays by ultra processed foods. they're delicious, they're convenient, they're relatively inexpensive. What are some of the mechanisms by which these seem to promote weight gain? I know that you've hinted at these previously, but what do you think are some key variables at play? So I'm thinking of things like energy density and palatability and maybe eating.
Yeah, I mean, the satiety per calorie, I think, is probably an important one. Um, and that encompasses energy density. So if you look at the 1995 satiety index paper, where they fed people 38 common foods and figured out, which foods were high satiety per calorie, which were low, and what properties correlate with that. The stuff that's low satiety per calorie is all it's kind of what you would expect. It's the junk foods, the highly processed calorie dense foods. The lowest satiety was croissants, and then there was candy, and yeah, bakery goods were at the bottom. Um, Candy and things like potatoes and oatmeal and fruits and fresh meats and fish. You think about these foods, they're mostly water. And I think that's a key reason why they have higher satiety per calorie and why they have a lower calorie density, which is related, is because when it's mostly water, you're eating more volume per calorie. It's filling your stomach up more. And that the stretch receptors in your stomach, that's a key signal to your brain that plugs into that satiety calculation. So yeah, so satiety per calorie, I think, is a key thing. And I think another one is high reward value. Another way to say that is high seductiveness. So these are foods that have properties that stimulate high levels of dopamine secretion in the brain, and that increases our motivation to eat them and reinforces our behaviors around seeking and eating them. So this is just classic Pavlovian reinforcement. When you have something that releases a lot of dopamine, it increases the probability that you'll engage in those same behaviors later. So you go to the pizza parlor, you eat the pizza, you get lots of dopamine. Your brain's like, oh, this is awesome. We got to do this again. And that dopamine surge, it rewires your brain to increase the likelihood that you'll go back there again in the future. And so you have all of these foods that are designed by, some of it just by kind of natural selection in the marketplace, some of it by intuition, some of it by giant corporations doing, massive taste test experiments and fMRI machines doing brain scans on people. And all of this basically means that the processed foods in a grocery store are going to be the most highly rewarding and seductive foods that are able to be produced with today's technology. And certainly far more than what our ancestors would have habitually eaten. And so these kinds of foods, many people would call them addictive, but I think that term is controversial, but I think you could absolutely accurately call them habit forming. Whether or not you want to call them addictive, they're definitely habit forming. And that explains why those types of foods dominate our diet. That, at least, let me rephrase that. That's a key reason why those foods dominate our diet. If you look in the US, but it's the same in almost any affluent country, um, something like 60 or more percent of our calories, 60 or 70% of our calories are coming from ultra processed foods. And these foods are seductive, they are convenient, and they are cheap. And that's the triple crown right there of uh, industrially processed foods. And that's why they dominate our diet, I believe. Seductive, convenient, and cheap. And, there are cheaper foods. You could be eating rice and beans. That's cheaper than these ultra processed foods. But rice and beans is not as seductive and it's not as convenient as these foods. And um so there's kind of this relationship that happens where these foods are both very calorie dense, not low satiety per calorie, and highly seductive. And so the seductiveness gets us to eat them and sometimes to overconsume them. And that low satiety per calorie causes us to overconsume them at individual meals. Um, and then you mentioned eating rate. That's an interesting one. I kind of historically ignored that because I felt like the data wasn't very strong, but I'm starting to come around to it as a possibility. I think there might be a concept that ties all this stuff together too, which is like how much work is this food going to make your digestive system do? And modern highly processed foods are basically minimizing the effort that your digestive system has to do. They're minimizing the volume of food in your digestive tract because they're very calorie dense. They have very little fiber. So that work of dealing with this fiber and water that's in whole foods doesn't have to happen by your digestive system. They don't have any like bitter compounds or digestive enzyme inhibitors that are found in whole plant foods. They're very finely ground up. Like there's no work that has to happen to break them down, either via your jaws or your stomach or the rest of your digestive tract. It's like everything is just easily accessible to those digestive enzymes with enormous surface area. So I think part of the calculation that your brain does when you're eating that determines how much you will eat is like it's a kind of a cost benefit, like how much energy is in this food versus how much work are we going to have to do to get this out. And if the work requirement is really low, then maybe your brain is going to say, hey, let's eat more of this because the cost is like zero. We might as well get this extra energy, on an intuitive level. I'm not talking about you're actually consciously having these thoughts, but these calculations are happening in non-conscious parts of your brain that determine your hunger and your eating drive. So that's just an idea that I'm tossing around right now.
A particularly salient example of that is the comparison between peanuts in their shells and peanut butter. Because if you think about peanuts in their shells, then there's effort involved in accessing them. But not only that, if you compare the subsequent peanuts to an equivalent mass of peanut butter, then the processing has influenced what is actually bioavailable for your gut to take up. And because the nuts have been broken down, ground down into a paste, more of the lipids are bioaccessible, and the actual energy yield is about 50% higher, going by some data that were published not too long ago. I know many of us have ended up with a jar of peanut butter in our hands at the
Yeah, and
fridge.
I think that's a great example because in that case, there's additional work required before you ingest it. So let's say you're having to shell the peanuts. I don't know if that's what you meant, but I'll just roll with that. Let's say you're having to shell the peanuts. And so there's additional work required before, and then there's additional work required by your digestive tract after. And even after that extra work, you might not even extract as many calories as you would from the peanut butter. So, yeah, I think that's a great example. And I think these kinds of implicit cost benefit calculations, we don't think about them consciously, but your brain is doing that math.
Scientists have come up with ways of classifying what an ultra processed food is, and these have changed over the years. But the current system that's widely used is the Nova system. But I don't think we need to get into that because many of us intuitively understand what these foods are. And instead, I just want to turn our attention to macronutrition because I understand that if you look at the proportions of macronutrients in the diets of people in countries such as the UK and the US, they haven't actually changed that much in recent decades. Needless to say, diet quality has, however. But can you touch on what we know about how specific dietary macronutrients influence energy intake and body composition? And can you focus in part on protein and fiber? Because I think those are so important for people who are trying to lose fat mass while holding on to their fat-free mass?
Yeah. So first, I want to comment a little bit on the thing that you started off with. There are people who argue that the so-called low-fat diet that we went through in the United States in the 1990s and 2000s is the cause of the obesity epidemic, or let's say 80s and 90s, really. Um, and I'm like, you look at the data, and there was barely any change in the proportion of fat to carbohydrate. Like, we're talking about 2 or 3 percentage points. And you're telling me that such a trivial change in the proportion of macronutrients caused a like threefold increase in obesity prevalence? It just doesn't make any sense. Um, so yeah, I think that argument is like, show me a randomized controlled trial where they increase somebody's carbohydrate intake by 3 percentage points and it makes them develop obesity. That's like just absurd. You wouldn't see anything. So yeah, I think those arguments are weak. But I do think macronutrients matter, and I the high level of it is that higher protein diets help reduce energy intake and body fatness. And as far as carbohydrate and fat, the most fattening proportions are right in the middle, where you're having a lot of both. And the most slimming proportions are where you're cutting out most of one or the other. And you can do that on either end, based on your preference and maybe some of your metabolic features. You could cut carbs or you could cut fat, but the most fattening spot is to have lots of carbs and lots of fat. And that's where we are in the modern US. That's where we've been for a long time. And but people go on low carb diets and they're able to lose weight. People go on low fat diets and they're able to lose weight. And if you squint at the data enough, maybe there might be more weight loss occurring on the low carb diets, typically in randomized trials, but it's not a large difference. Um, and you see this in the rodent studies too. It's the same in rats and mice. If you give them lots of fat and carbs, they get fat. If you put them on a ketogenic diet, they get slim. If you put them on a low fat diet, they get slim. So it's really that middle zone that's the danger zone. And when I say danger, I don't think it's inherently unhealthy. I just think it's the place where it's easiest to overeat. And I don't think we have really great evidence on why that is. Like, I can't say with great confidence what the mechanism of that is, but the only thing that I know of that I'm aware of that really has the capacity to explain that right now is food reward. So essentially, when you're eating both carbohydrate and fat, that's the place where you're maximally stimulating dopamine release in your brain, maximally stimulating eating drive and reinforcing those eating behaviors. And so if you cut out a major class of dopamine stimulating nutrients, like carbohydrate, for example, even if you eat more fat, that's still not giving you the same kind of dopamine release that you get by eating both. And so, um, that to me is the only explanation that we have that really makes sense for why either end of the spectrum would have a similar effect. Like, you can't really explain it by saying just like carbs are fattening, like some people have tried to do, because then why would a high carb, low fat diet be slimming? You can't explain it by just saying fat is fattening. Why would a low carb, high fat diet be slimming? Neither one of those hypotheses explain all the evidence we have. So that's the explanation that I know of that makes the most sense, but we don't have strong evidence that that is actually what explains it. So, um, you can take that for what it is, as a hypothesis. And yeah, so we covered protein, we covered carbohydrate and fat. I think those are all pretty major levers over energy intake that can be modified. And then you mentioned fiber. That's also a lever that can be helpful. Probably a little less powerful those variables that we previously talked about, but higher fiber does tend to lower calorie intake. Yeah, so eating more whole plant foods like fresh fruits and vegetables, as long as you're not totally dousing your vegetables in fat, um, those are things that can help reduce overall calorie intake.
Just to add a few thoughts. One is that if you look at how people distribute their protein intakes across the day in countries like the UK or North America, then most people have a large bolus of protein at dinner, a modest amount at lunch, but very little at breakfast. And actually, there's probably a threshold amount of protein that you want on a per meal basis for a few reasons. One of them has to do with muscle protein balance. It seems that there's a certain amount of the amino acid leucine in particular that's needed to maximally stimulate muscle protein synthesis, which is the main determinant of whether your muscles are getting bigger or smaller over time. And that's very relevant in the context of a negative energy balance because you're trying to hold on to as much fat free mass as possible. So simply adding some breakfast protein is really helpful for many people, not just because of the effects on muscle tissue, but also because protein has such strong effects on satiety. It improves glycemic responses to meals. And if you look across the 24-hour day, then it does seem to affect later meals too. And so, moving on from macronutrients, several so called personalized nutrition businesses, such as Zoe, have become remarkably profitable in recent years. They've played their hands very well indeed. And I certainly don't want to sound cynical because my impression is that their offerings are getting much better over time and they're helping many people. And companies like Zoe and Day2 are publishing good science on their interventions too. But at the same time, I don't think many people realize that some of the foundations that these personalized nutrition businesses are based on are somewhat shaky. And just as an example of this, Stefan, I know you're friends with Kevin Hall. He recently published a preprint that was playfully entitled Imprecision Nutrition, showing that if people use two continuous glucose monitors concurrently, their responses to standardized meals are all over the place.
That's crazy. That's crazy.
Glucose data from these devices are at the core of what these businesses are doing. And the data are then used to modify their intervention so that people can personalize their nutrition appropriately. And then some of these businesses will also use things like stool samples. And my impression is that, frankly, we don't understand how to interpret those data very well right now. And instead, some of these businesses are really trying to generate vast data sets that they can then mine so that we can better understand the gut microbiota specifically. So, do you think that existing personalized nutrition products are a step forward yet compared with canned dietary advice based on what we know works well for most people?
I think that the concept of personalized nutrition is logical and promising. I think that I have little doubt that people respond differently to different interventions, whether it be dietary or physical activity or other things. And so if you can figure out in advance who's going to respond best to what, theoretically, you should be able to target interventions more effectively. So I think the concept behind it is sound. But the question is, can you predict in advance who's going to respond best to what? And I think that's where things are not very convincing to me yet. So, my position on this is simple: show me the evidence that it is more effective to do this. Show me the evidence that your targeting algorithm is more effective than just giving people a generic diet. And that's the evidence that I haven't seen yet. So when I see that, then I will be convinced. And until then, I will not be convinced. And, but again, I think in theory, I think, like, obviously promising to me that it would be, in theory, possible to do that if you had the right information. I think getting that information is difficult. Um, I think that it's very conceivable that someday we could tailor people's diet and lifestyle based on genetics. I don't think we have the power to do that now, but it's very conceivable to me that we will be able to someday. And people, they experiment and they figure out what's best for them, and any given individual usually will find that some things work better than others, and that's not necessarily the same as some other person. So I think there are strategies that work better and worse, but finding them is challenging. And especially when it comes to the microbiome, I will say that I'm thoroughly unconvinced at this point that there are causal effects of microbiome on body fatness. I think the evidence supporting that is basically nil right now. Even the evidence in rodents is not convincing. So I'm not saying that it's not like implausible. It's not like it's impossible that this could be a thing, but the evidence right now is just not convincing that it is a thing. So the idea that you could measure someone's microbiome and know what kind of diet they need to be on more than, that would be more beneficial than just generic diet advice. There's like zero basis for that right now, as far as I'm concerned. So I'd be especially skeptical about microbiome. Um, there is one area that's kind of borderline, maybe controversial, um, but there might be some value in it. There is some evidence that people who are more insulin resistant tend to do better on low carb diets than low fat diets in terms of weight loss. I think in terms of metabolic health, I think the edge goes to low carb diets for people who are insulin resistant or have metabolic syndrome. In terms of pure weight loss, it's more controversial. Um, there are some studies that weren't really designed to test this, that have shown um, that there is a difference. However, the one study that was designed in advance to rigorously test this hypothesis did not find that it was supported, and that's the Diet Fits trial. So there was no difference in weight loss um, between low carb and low fat diets that was determined by how much insulin people were secreting. There was no relationship. That was not a determinant of how much weight you lost on each diet. So, yeah. And I think we don't, there's no good marker right now for how much weight people are going to gain, how much weight people are going to lose. Like, there's no physiological marker that reliably predicts that. So I think we're a pretty long ways off understanding the physiological basis for these types of effects or types of differences.
Moving on to physical activity, I mentioned controversy earlier, and Herman Pontzer's spearheaded the idea that energy expenditure is somewhat constrained. And so, for many people, increases in physical activity aren't necessarily going to substantially increase total daily energy expenditure according to this model. But others have pushed back, suggesting that there are flaws in many of those studies on which that hypothesis is based. And some scientists from the University of Bath and elsewhere recently wrote an excellent critique of the constrained energy model. My own perspective is that, minus certain exceptions, physical activity probably doesn't affect adiposity that much via energy expenditure, and it probably does more so through regulation of energy intake. But I was just wondering if you had any brief thoughts on that particular subject.
Yeah. So, I haven't read the new paper critiquing the constrained energy expenditure model, but I know that it was well received. Um, and I think so. Okay, I'm not an expert in this area. The experts are continuing to debate it pretty hotly. So I think where I'm at right now is that I think there's probably at least some truth to the hypothesis, to Herman Pontzer's constrained energy expenditure hypothesis. If you look at randomized, this is basically where I'm coming from with this. if you look at randomized controlled trials of exercise interventions where exercise was supervised and monitored, so they actually know how much exercise people were really getting, and they were kind of enforcing consistency. What you see is that in those types of interventions, people's total energy expenditure, so the total amount of energy they burn over a 24-hour period, doesn't increase by as much as you would expect based on the amount of energy they're burning in the physical activity. And so, it's not totally constrained. It's not like there's no increase. But then again, if you look at Herman's hypothesis, he's saying that it takes a long time for this effect to kick in. It doesn't kick in on a day-to-day basis. Your body adapts over months and years. And these interventions typically were less than a year, so maybe 6 months. So you wouldn't necessarily expect to see full compensation, and you might expect to see partial compensation, and that is what you see in these trials. And so, um, to me, like, that is some of the strongest evidence we have right now. Maybe we'll end up with stronger evidence. Um, but I also kind of think that I tend to think the truth might be somewhere in between. I am skeptical that energy expenditure is fully constrained. I think it probably responds somewhat to physical activity, but probably not in the same one-to-one manner that we assumed it did for a long time. So that's kind of where I'm at right now.
It's probably neither constrained nor additive, but somewhere in the middle. And I want to move on from exercise, but I'll just add one more thought for people, which is that if you look at people's weight trajectories over time, then you tend to see quite long periods of stasis where people are more or less weight stable, and then spurts in weight gain that coincide with the holidays, sure enough. And during these periods, obviously, there's an energy imbalance that's driving that. And when you think about exercise, I really strongly recommend that people do resistance training throughout the holidays. Because if you're doing resistance training that provides hypertrophic stimulus for your skeletal muscles, then you're going to shuttle more of those excess calories to your fat free mass. There's going to be an energy partitioning effect that's going to help protect you against gains in fat mass that are going to worsen your health over time. But I realized that we only have so much time left, Stefan. And so there are a few subjects I'd love to just briefly get some of your thoughts on. And one of those is weight loss surgeries, surgeries for obesity. And there are three main types of these, but I was wondering if you could just give your perspective on them, because I think some people would intuitively think that they must be very dangerous when actually that's not necessarily what the research shows. And also, do you think that they're still the gold standard, the most efficacious interventions for obesity, given the dramatic recent progress in medications?
Yeah, so bariatric surgery is, I would say, quite safe these days. It used to be a lot more dangerous, and I think in the early days, the mortality rate from it was pretty significant, like approaching 1%. And now it's much lower than that. It's like less than 1 in 1,000. And you might still think, well, that's a lot, but consider that remaining with severe obesity is a lot more deadly than that. And when you look at follow-up studies of these people, they're all people who undergo surgery versus people who don't with severe obesity. All-cause mortality is quite a bit reduced in the people who undergo surgery. So it really improves health quite a bit. And that expresses itself as a reduction in cardiovascular events, reduction in type 2 diabetes diagnoses, a reduction in cancers. Basically, all of the leading causes of death are reduced by bariatric surgery. And let me clarify that I'm talking specifically about the more effective common types of bariatric surgery, which are Roux-en-Y gastric bypass and sleeve gastrectomy. And um, those I would say are still the gold standard for weight loss in people with severe obesity. So typically what you're going to see with those two types of surgeries is you're going to see uh, initially something like a body weight loss of about a third of body weight. And then over the course of the next few years, people will regain some of that and they'll stabilize around a quarter of body weight below their initial weight. So even 5 years later, people are still at like 25% body weight loss. So it's really a very effective method. There's nothing else now in common usage that even approaches that, and certainly no kind of diet or lifestyle approach is going to do that in the average person. And um, so now we have these new drugs, the GLP-1 receptor agonists, and um, some of them have other things like GIP or glucagon also. Um, and those are causing large weight losses. So now we have some drugs that are approaching the amount of weight loss that you see with bariatric surgery. So tirzepatide, for example, in people with obesity causes at the highest doses over 20% loss of body weight. And so this is getting close to bariatric surgery levels. And there are some even newer ones that are not approved by FDA or EMA yet, but are going through clinical trials that cause even more. And so we are getting to the point where the line is being blurred between weight loss drugs and bariatric surgery. I think there is a point, though, to be made here. A couple of points. One is that bariatric surgery is a lot more cost effective in the long run. It costs a lot upfront, like 10 or 15,000 US dollars. But if you consider that that is like less than a year's worth of Wegovy, which is semaglutide, then you can start to see why it's cost effective. And the other point is that it's a lot more constrained. Like bariatric surgery, the supply is more constrained, I should say. Bariatric surgery is not going to be the solution to the obesity epidemic. It's just not scalable in the same way. Or if it is, it's yeah, it maybe theoretically it could be, but it doesn't seem like it's going to be. The number of surgeries that are happening each year is just way too small to make a big dent in the obesity epidemic. And a lot of people just don't want to have surgery, major surgery on their bodies. It's an irreversible procedure. So even though it's really helpful and most people really are glad they had it, it's understandable that someone might not want to go through a procedure like that.
As you were speaking about pros and cons, another thing that just popped into my head is that if, for example, you start taking semaglutide once a week, that also involves subcutaneous injections for as long as you're going to use it. And as far as we can tell, when people stop using these drugs, they just start going in the direction of where they were previously. And so the reality might be that people will have to continue to use these drugs, albeit possibly less frequently and at lower doses, to maintain a substantial amount of their weight and their fat loss over time. But if you look at all of those different drugs, Stefan, including those that are currently in development and not necessarily in phase 3 clinical trials yet, are there any that pop out to you as being particularly interesting?
Yeah. Um, there are a couple of them. There's one, I can't remember the name of it, but it's a tri-agonist, meaning that it hits three different kinds of satiety receptors: GLP-1, GIP, and glucagon. I think this is Pfizer. I can't remember. I don't remember the details. Um, but there was a trial that came out recently. I forget if it was phase 1 or phase 2, but it was like, and again, I'm fuzzy on the details, but it was something like a 20-week trial, not a full year. It was closer to 6 months. And the weight losses were insane. Like it was something like 17, 18% weight loss for just 6 months on this drug. And it was nowhere near plateauing. Like people were still in kind of in free fall in their weight loss. And so, you extrapolate out and you're looking at mid 20s plus of total weight loss. Um, in theory, assuming it extrapolates out like that. Um, and so that one is very promising. And basically you know, the preclinical work, the work in rodents has kind of gone in this direction of adding additional agonists onto the same molecule. So in other words, having a drug that's hitting multiple satiety receptors at the same time in the brain. And this is the first time they're going through the clinical trial pipeline with a triagonist, one that hits two. So three. Tirzepatide hits two, semaglutide hits one, and this new drug hits three. And so this is just like it's amazing how things have been flowing from the rodent research into the human research and just been highly effective. Um, that doesn't always happen. Doesn't always happen like that. And yeah, so that's one. There's also um, amylin, which Novo Nordisk has been working with and combining that with semaglutide. It's called pramlintide. It's a synthetic version of amylin, which is another one of these satiety hormones. And so that combination shows really impressive weight loss. The results are pretty similar to what I just described for this other triagonist. And then there's another one that I think is pretty cool. It makes people gain lean mass while losing fat mass, and improves their blood glucose control. So it's kind of like if you've heard of the myostatin
Yeah.
null animals, the like
Yeah. Google
whippets who
them.
are super muscular, and the Belgian blue cows. Yeah, Google Belgian blue cow. Just trust me. Um, and you'll see what a myostatin null mutation looks like. And this antibody is basically targeting the same pathway to increase muscle growth, and it also causes people to lose fat and get better metabolic health. So that one's pretty interesting. I don't know how it's going to fit in terms of like where it's going to fit in the medical management of diseases, because it's not a great weight loss drug compared to these other ones. And increased muscle mass is good, but that's not really like a common clinical target. So I'm not really sure how it's going to fit in, or in terms of whether it's going to get funded to go all the way through, FDA approval, and if it does, how often it would be used.
I do worry that with some of these new drugs that are causing such rapid weight loss, and you spoke there about how this triagonist might cause around 1% loss per week, you're going to experience a substantial loss in fat free mass too. And so, possibly the combination of some of these weight loss medications with agents that are going to help preserve fat free mass, which could be bimagrumab, it could be something like testosterone for men, might be particularly appealing for many people. And just to tie a bow around this section, I'll add a couple more thoughts. And one of those is that I do find it frustrating that right now, the people who need these medications the most aren't necessarily the people who have access to them. And I don't want to sound like I'm preaching or anything like that, but the reality is that because they are so expensive, a lot of the people using them are wealthy people who are accessing them privately, and they're using them to quickly shed a few pounds ahead of beach season or wedding season. And that is unfortunate because there are people who really need these medications. And with that out of the way, I'd just like to close, Stephan, by pointing people to an article that you wrote, and it was for Asterisk magazine because I read it recently and thought it was terrific. And it focuses on the harms of nutrition misinformation, which I know is a subject that's close to your heart. You founded Red Pen Reviews, which I will also link people to in the show notes. But I was struck by the results of the model that you built. And I know that the model that you built, that you'll find if you go to this article in Asterisk magazine and follow the link, is crude. When you look at the potential deleterious effects of nutrition misinformation in terms of lives lost each year, it seems that we're talking about something that's actually quite substantial. And you draw some interesting comparisons in that article. Could you speak a bit about how damaging you think nutrition misinformation might be, and then also about the efforts that you're making?
Yeah. So I'll tell people a little bit about this model and why I did it. I was writing this article for Asterisk magazine, and it's on nutrition misinformation. And one of the key questions that I had was, what is the burden of nutrition misinformation? What's the public health burden of it? How much damage is it really causing? And so I started doing scientific literature searches, and there was no published estimate. There was not a single published estimate of the total amount of harm caused by nutrition misinformation. It seems like nobody has even tried to estimate it. And so when you look at like review articles that mention, what harm does this do, they'll just like look for case studies in the medical literature of people who uh, died as a result of nutrition misinformation. And when you do that, you come up with like a handful of case studies of somebody that took a supplement that was mislabeled and they overdosed on vitamin A or, something like that. And I think that's just a gross underestimate of the amount of damage that misinformation is causing. I think most of the damage is coming through people making suboptimal diet choices that slowly accumulate over the years and decades and cause them to have adverse health outcomes later in life. And that's the kind of thing that you're not going to find in medical case reports, right? Because it's really hard to identify. And so basically what my model tries to do, and by the way, we have no idea either how much nutrition misinformation is influencing people's food choices. So it's like really hard thing to model. And you have to guess at certain parameters. But we do know that something in the range of 14 to 22% of all deaths in the United States are thought to be caused by suboptimal diet. And if we assume that even just 1% of that suboptimal diet is caused by nutrition misinformation, that's 5,000 deaths a year. And so any reasonable guess that you might make about how much misinformation is affecting our diet in the US is going to lead to a number that is far higher than people commonly appreciate in terms of the number of deaths that's caused. So in my model, I guess that it's somewhere between 1 and 20% of our diet choices, of our suboptimal diet choices, are caused by misinformation. And that leads to, I think the range is like 4,000 to 120,000 or something like that, premature deaths a year in the US alone. And those are kind of my lower and upper bounds. And those are guesses, but if you don't like my guesses, make your own. And the rule of thumb is for every 1% of our suboptimal diet choices that's caused by misinformation, that's 5,000 premature deaths a year, roughly. And so think of the figure that you think is reasonable and do the math. And I think most people will come up with figures that are not negligible. And yeah, so I think it's really been surprising to me also how little of a splash this has made. Like, I think nobody's ever built a model like this. And I think, whatever you think about the guesses that I made about how much of our diet is caused by misinformation, like, the fact remains that any reasonable guess you might make leads to a number that is far higher than we previously thought. And so, like, it's been surprising to me how little impact it's been having. It's like, I don't know. It seems like there's, at least in the academic community, there's not much interest, not much funding for misinformation.
In the article, you also draw some comparisons between other causes of deaths in the US each year. And to put those figures into perspective, you compare those numbers to traffic accidents plus gun homicides, then they're still way below the upper bounds of the model. So we're talking about something that could be enormously
Yeah.
burdensome at societal level.
Yeah, exactly. Yeah, it's very plausible that nutrition misinformation kills more Americans each year than road accidents and gun violence combined. And those are two things that we care a lot about, right? Like, there's a lot of public conversations about them, there's public health initiatives around them. Um, that is a level of burden that we care a lot about. And so it's interesting to me that nutrition misinformation is not getting the same kind of attention. And I want to explain a little bit to people why my guess is from 1 to 20% of our suboptimal nutrition choices are due to misinformation, because you might think 20% seems like way too high. And maybe it is, by the way. That's a guess. So that's my upper bound. Maybe it is too high. But I think I want to help people understand where I'm coming from with that. Um, there are different kinds of misinformation. Some of them are the kind that you would get from a diet book or from reading stuff on the internet. I think that kind of misinformation is really, really common. Um, like, for example, one that I think is particularly damaging is the idea that LDL cholesterol is fine, and high LDL is maybe even good for you, and eating foods that increase your LDL is not a problem, and maybe we should even seek that. That's a really common piece of misinformation on the internet. But also, a lot of the misinformation that I think affects our daily lives comes from food product packaging. So, just to give you an example, if I can only speak to the US here, but I'm guessing it's similar in other countries. If your intention is to buy 100% whole wheat bread, you can very easily be misled by product packaging. There are all kinds of other terms that sound like whole wheat, but are in fact predominantly refined flour. So, for example, there is, it could say multigrain. Um, Typically, breads labeled multigrain are based primarily on refined white flour. It could say contains whole grains. Um, and there are a couple of others I can't think of off the top of my head, but there are a lot of terms that manufacturers use on product packaging that imply that it's 100% whole grain when it's not really. So it's like the consumer gets to feel like they're, buying something healthy, but they also get this tasty white flour bread. Um, and there's a lot of stuff like that. Health claims on packaging is very, very common. And sometimes that is helpful. Sometimes it actually helps consumers make better choices. But some subset of that information is, in fact, misinformation that makes people make poorer choices. And I just gave one example, but there are many others like that. Like, sometimes, sugar sweetened beverages will say like vitamin C added, as if that's gonna, make that a healthy beverage. And yeah, so I think that is just to give you a sense of one of the types of misinformation that I think could be particularly impactful of people's food choices.
And Stefan, you've been very generous with your time. I realize you've got to get back to your day job, which is as a researcher at GiveWell. And I was exposed to effective altruism for the first time, I think, when I read William McCaskill's first book. And after that, I actually had coaching through 80,000 Hours, which is probably a company that you're familiar with. And they take an interesting approach to career
Mm-hmm.
guidance for talented people, where they basically encourage people to look at roles in which people have a good personal fit. The problem is burdensome the problem is tractable and the problem is neglected. And to me, your work on nutrition misinformation is a perfect example of something that meets those criteria. So I'll just finish by saying thanks so much for your work. I really appreciate it and I admire what you do.